right. Well, good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. Busy November already on the go. I think we've already done probably 20 live lessons for classrooms. Last week, we had our CNN Call to Earth Week, connecting with scientists, explorers, adventurers, conservationists from all over the world, sharing their stories from the front lines of our changing planet. And then this week and for the rest of the month, we have a theme of archaeology, paleontology, and geology on the go. So visit exploringbytheseat.com. You can find all those live events we have coming up. And a new newsletter went out a couple days ago as well. So we hope to see your classrooms joining in some of those events. Today, we are going back out into the field. We are catching up with an expedition team we've been following for several months now. And that team is the Around the Americas expedition. So this is a 14-month voyage that launched in May. They will circumnavigate North and South America aboard the 48-foot sailboat One Ocean. The mission focused on scientific research, education, and community outreach to raise awareness about ocean health. This builds on an original journey, 2009-2010, and they're going to be able to compare the oceanic changes that they're seeing in the last 15 years. And a big part of this project is exploring our incredible underwater kelp forest that we have wrapping around various parts of North and South America. So they started the trip up in the Washington area. They have gone around the west coast of Canada, through the Northwest Passage, along the east coast of Canada and the US. Last time we caught up with them, they were in Bermuda. So let's see what's going on with the team now. Let me grab them from backstage. Here we go, coming in now. Hey everyone, how we doing?
Hi.
Hi Joe. Hi everybody. Thank you so much for joining the crew here from the Around America's expedition. I'm Jennifer Dalton.
And I'm Mike Beamer.
I'm Tess Shortak.
And I'm Mark Schrader.
And we have...
Hi, I'm Grace. Hi, I'm Grace. I'm the lead onboard scientist for the boat.
So anyway, we are here in, we just made it to Puerto Rico late last night, and very, very hot, and we're actually at a marina, just rolled in this morning to the marina, and we're here to re-provision to kind of our next big event, right? Because we're going to be going, possibly this could be our last stop in North America. So we've got some re-provisioning and all kinds of stuff to get done for the next few days here.
Yeah, and the next leg of the trip is really a long leg. It's 3,000 miles down through the South Atlantic and coming back into Uruguay. So it's a long run. But we've had a couple of weeks here. We've had a really interesting 3 weeks of a big storm in the North Atlantic coming down from Halifax. And we got into Bermuda just in time to have a close-up and personal greeting with Hurricane Melissa. So we sort of had a double thing happening, so it's been a rough 3 weeks.
Yeah.
We're delighted to be in Puerto Rico.
Well, it truly, it's been a huge comparison of, their 2009-10 expedition. We have been encountering storm after storm after storm and really big stuff. And truly, we went through Hurricane Melissa, and we're very grateful that she came to us as a Category 2. We didn't experience what poor Jamaica had to go through. But it has been an eye-opener of how different things are from 15 years ago, and it's pretty extreme, and we've had some wonderful scientists capturing a lot of this stuff. Our next classroom too, we have Andy Jessup that will be joining us, and he's going to be talking about some of the data that he collected as we cross the Atlantic, which is going to be really interesting stuff. And then we have Dr. Jim Thomson today, who has also been a huge help in collecting data through these MicroSWIFT buoys, and that's what we're going to be talking about today.
There it is, right there. Yeah. And one of the takeaways right here, just in the past 3 weeks, the sea surface temperature, we're recording that every hour. Sea surface temperature from Bermuda here was in the 90s, 90 to 91 degrees. And in the Arctic, remember we talked about, we were hitting temperatures in the 60 degrees, even though there was ice around, it was 60 degrees. And then through Nova Scotia and on down here, it got into the 70s. But down here, 90-degree water for the past 2 weeks.
Yeah.
And we've deployed 3 of these, right?
Correct.
Three of these so far in our expedition, and we're going to continue to do it. But today, we'll talk about they will talk about how these are put together and what they do and measure and stuff, but we deployed 3.
Yeah, we deployed one here coming out of Alaska over to Aleutian Chain, one over
In the Davis Strait.
in the Davis Strait.
Coming out of Canada, coming south.
Yeah.
And then one down here close to the Gulf Stream. I forgot.
No,
South of
it's
Sargasso.
Sargasso Sea.
Yeah.
Yeah, the Sargasso Sea.
Unfortunately, that one didn't work so well for us, and we also were going to try to do it in the Gulf Stream, but we had such extreme weather, we weren't able to deploy it. We were really in a, everybody, all hands on deck. Everybody had to be really focused at the wheel, so we weren't able to do it there. But once we leave Puerto Rico here, we will drop another one, and we were able to dedicate this last one to a bunch of kids in Ukraine, and that was really exciting for us. And we've been able to chat with them and answer some questions. So that's been a really exciting trip, but lots going on for us, and we've been pretty tired.
But we're okay.
But we're all okay, and One Ocean is okay. And
Yeah, let's hear about these buoys.
Yeah.
All right. I'm going to bring Dr. Thomson in just a moment, but I'm not going to let you off that easy. When we left you, you were just getting ready for that hurricane to kind of reach where you were. So, I'm wondering, I'm sure the classrooms are wondering what it was like on board the ship during that time. Did you miss some of it? Did you hit the outskirts of it? What happened?
Yeah, it tracked a little bit north to us, but we actually clocked 82 knots of wind, which I don't really even know how to describe other than
Describe it.
it was
loud.
loud. It was like a freight train. So what we did is we spent a few days repairing the boat when we got to Bermuda, but then we had to take everything down again, all our sails. We worked really, really hard for days. Captain Mark here, he has just such a wealth of experience, so he really knew how to kind of keep us focused, what we needed to do to be safe while we were out there. And then we talked to a lot of locals, and the locals directed us into a bay where we should go. And we experienced a lot of the wind, but the fetch, which is where the swell, it goes up and down like that, we were safe from that, and that was really big for us. So really, we had everything buckled down, tidied up, and put away.
We had 2 anchors because as the hurricane passed, the wind switches direction, and that's always super hard when you're anchored in small bays. So a couple of anchors.
And a lot of really good local knowledge help. We tried to get everything off the boat that might blow away or damage something else. We tried to anchor away from as many other boats as we possibly could. Turned out we anchored pretty close to an island. And we just happened. We did drag anchor at the height of it when the 80 knot gust hit, and they felt it. So then we had to end up powering into it. We had the engine running most of the night, just giving us a little forward thrust. We got so close to the bushes on the little island that we could have probably picked fruit, but it was blowing all over the place. So it was a pretty exciting night, but it was nothing. It was forecast to come right over Bermuda, and the winds then would have been over 100. It missed us by about 50 miles, but the outskirts of those winds lingered for 20 hours. And they were pretty strong winds.
Pretty strong, very loud. I have to say, the noise of it is so intense. It's a little scary. I do feel for people who have to experience that on a regular basis, and a lot of people do now, and the intensity of these hurricanes are only increasing. What happened down toward Jamaica was they were saying that the seas had been so warm and calm for quite a few months that hurricane really sucked up a lot of that energy, and so it's pretty difficult.
Difficult. We were lucky.
All right. Well, we're happy to hear that you guys made it through okay, that the boat made it through okay, and you made the crossing to Puerto Rico. So sounds like it all ended well, which is always good.
Thank you. It did.
Thank you. We did have a good crossing across here. So we sailed most of the way, and that was fantastic.
Peculiar thing about that, from Bermuda here, it was 800 miles. 900 miles. We saw no birds, no bird life at all until we were day out of here. That's really unusual. And with 90 degree sea surface temperature, peculiar. And we saw some flying fish, and that was it.
Yeah, lots of flying fish.
Lots of flying fish.
All right. Well, it is time. We have Dr. Jim Thomson hanging out backstage. He studies waves and turbulence at the ocean surface, including interactions with sea ice. His work emphasizes field measurements and physical processes and includes the development of instrumentation, like that MicroSWIFT Buoy Tracker that we have right there. I believe we deployed 2 of them live so far on the expedition with classrooms, so that was pretty cool. And I know that Jim, he moves around quite a bit because it was not that long ago that I was hosting him and some of the other researchers on board the research vessel Sikuliak in the Arctic Ocean above Alaska. So let's reach backstage. Let's get Jim in here. Hey, Jim, how are you?
I'm great. Nice to be here.
Yeah, good to see you. Good to see you on dry land. I'm sure the expedition was great. And it was a pleasure to connect twice and check out some of that really cool work that you guys were doing around the sea ice and the wave action. And that was fun to share with classrooms.
Great. Yeah, I'll touch on that at the end. But first, I thought we'd talk about these buoys, how they work, and what we do with them.
Perfect. All right. Well, I'm going to let you take over for a little bit. I'm going to tuck everybody else backstage. And for now, the floor is yours.
Okay. Are you seeing the right slide? Are you seeing a big picture of a wave and a buoy?
Yep, looks good.
Okay, great. Yeah, so the buoy in this picture is a swift buoy, and what they're holding there from the Around the Americas team is a MicroSWIFT buoy. So I'll explain the difference in a minute, but basically one's a lot smaller than the other. And this is a big breaking wave that came over the top of that buoy, and that's one of the things that I study and my lab group studies, is trying to understand those waves. And the first thing we have to do to understand anything is to measure it. So that's what these buoys do. And I'll talk you through that. But first, I just want to give you a picture of what it looks like when it's really rough out. So this team just went through a really massive event, a hurricane passing over, and this video is a little bit similar. It's when the ocean is really active and there's very strong winds, and this is on a big research vessel, so a lot bigger than the One Ocean vessel. And you can see even this big vessel is still moving around a lot, and the winds are really strong. And if you're prone to seasickness, this is a day that you might get really seasick because the waves are big and the waves are breaking. And when you get conditions like this, there's really a few things that are happening all together. The first is that it has to be really windy. That's how you make waves. You need a lot of wind to make big waves. But then the speed of the wind is not the only thing. There's more to the story. For the waves to form, they need 2 additional things. So you've already got the wind. That's sort of the 0 part. You have to start with that. Part 1 and 2 is how long the wind has been blowing, the duration of the event. So if the wind's been blowing for a lot longer time, that allows the waves to build up more. We say the waves mature. They over time they get bigger, and because they've had more time to grow. And then the second thing is the space, or the fetch. And the One Oceans team, they already mentioned that fetch was really important for their consideration for where to place themselves to ride out the hurricane safely. So you need time and distance for the wind to do its work and build up the waves. And that's one of the things we're always looking at when we put wave buoys in lots of different places around the world's oceans. We're trying to understand how those things all come together to make conditions like this. And conditions like this have lots of importance for the ships that are at sea, for them to navigate safely and make decisions about their wayfinding, their routing, where to be, when to be. But they also have lots of importance for people who live at the coastlines, because these waves come into the coast and they can cause a lot of erosion and a lot of damage. And then the waves also, they're a big part of the climate system. Every one of these waves that's breaking, making all that foam, all the white cap that's made there, that's where the ocean and the atmosphere can exchange gases. That's where there's bubbles being put into the ocean, and the ocean will take up oxygen by doing that. That's really important for all the biology. The ocean will take up carbon dioxide. That's important for our climate system. And lots of other gases. There's a lot of exchange that happens between the ocean and the atmosphere every time you see a white cap like this. So there are lots of reasons to understand these waves and measure these waves. And the thing we always come back to is, how strong is the wind? How much time has it been blowing? What's the duration? And what's the space, the fetch over which that wind can work and build up the waves? So now I want to give you a cartoon of what a wave buoy does. What a wave buoy does is it rides the waves and moves around with the waves. So this cartoon shows you with the little orange dot, that would be a wave buoy at the surface. And this would be how that buoy moves as the waves pass. And there's a bunch of interesting things in this cartoon. It's a cartoon, but it's actually quite realistic. It does have all the right motion for what's happening. So the first thing I want you to notice is that the buoy, the orange part, it just goes around and around. we call that an orbit. It's the same word you use for the solar system, but it's a much smaller scale here, but it's still an orbit. It goes around and around. And as it traces out that orbit, you'll notice that it doesn't actually go very far. It doesn't move that much, even though the wave that runs across the screen from left to right, that moves a lot. And this is one of the neat things about the physics of waves that has analogies to lots of other waves too, like sound waves or light waves or other waves in the physical environment. Waves can travel far and fast, and they can carry a lot of energy, but they don't tend to carry matter or mass. So if that orange dot is a buoy, that has matter, right? That's a piece of mass, and it's just going around and around. It's not really going anywhere. But that wave, it's going left to right across the screen. It's really moving. And the analogy you can think of is if you've ever been to a sporting event at a stadium and you've done the wave with the crowd does the wave. If you're participating in that, you stand up and sit down, or you put your arms up and arms down, but you don't go very far, right? You don't actually leave your seat. And yet that wave goes around the entire stadium and can do it pretty fast, probably faster than you could run around the stadium. So that's another example of a wave as a signal, and it carries energy and it carries information, but it doesn't carry matter. The mass doesn't move very far. So that's the same thing that happens with ocean waves. And that's what this little buoy does, is it rolls around at the surface. Another thing that's interesting about this is to look at the little orange dot below. And we do sometimes build things that stay below the surface, and they can also measure wave motion. They just have less motion. So we say that the wave energy attenuates the deeper and deeper you go. So if you go down further and further into the ocean, the wave energy, the signal gets smaller and smaller. And that can be a really good strategy that some animals use and some people even use to ride out a storm, is just get below the surface, and it'll be a lot nicer below the surface. It's one of the things we do when we work up in the Arctic. If there's heavy sea ice and the sea ice might break our instruments, then we put the instruments below the surface, and we can still detect the wave signal and measure the wave signal, but we can do it without big pieces of ice crunching and causing problems and breaking our equipment. So a couple different interesting things in this graphic. So I want you to think about what that wave buoy being the orange dot, and it rides around and around. If we can measure how much is moving, then we can measure how tall the waves are, the amplitude of the waves, or the height of the waves. So the height would be from the crest to the trough, from the top to the bottom. That's the metric we usually use. And we also measure their spacing. That would be their wavelength, how far apart they are in space. Or we can measure their period, and that would be how far apart they're separated in time. So there are all these different metrics that describe how tall and wide the waves are. And that's what we do with the buoys. We keep track of all of that. Here's a more realistic picture on the next slide. This is a buoy that's going up and down. And what you're seeing is a 3D reconstruction of the waves, because sometimes we also use stereo cameras to measure the waves. And then we can reconstruct the entire wave field with these stereo cameras, and we can see how the buoy's moving in the wave. Okay, so what do these buoys actually look like? Well, you saw one there. The team has one in hand that they're looking at, and here's a little bit more information on those. These buoys are smaller than our big buoys, so we call them MicroSWIFTs. And the idea was, a couple years ago, we thought, you know what, if we could make these really small and we could make them cheaper, then we could build a lot more of them. We could offer them as a tool for other teams that are out there working in the ocean, and we could even deploy them from airplanes. So the picture there on the left is Jake Davis. He just earned his PhD working in our group, and he participated in one of these live streams a couple months ago. And he was studying hurricanes by deploying these buoys just ahead of the hurricane from airplanes. They call these airplanes the hurricane hunters. They go out and they study and make measurements of the hurricanes. So he got to ride on some of those and put these buoys out. And he also helped to get design and build these buoys. So he's an example of someone who studied a lot of math and science when he was a younger age, and then decided he wanted to go to grad school. And he got to do some of the engineering to help build the buoys, and he got to do the science using the data from the buoys. And you can see in the bottom left corner, there's a picture of some of the team helping assemble and build the buoys. And we had people that were undergraduates and professional engineers and graduate students all working together to help build these buoys. So here's a little bit more detail on what those look like. A schematic where it all expands and you can see what's in it. It's a small cylinder. It has end caps and O-rings that keep everything inside dry. It keeps any water from getting in, and that's an important part of the design because there are electronics inside that don't want to be wet. It has some batteries inside that are just the kind of batteries you would buy at a hardware store. And then it has an electronics board that has a little computer on it, and that makes some of the calculations. It has a GPS receiver, so the buoy knows where it is. It can receive its position. And it has some instruments to measure motion. It also measures motion with a GPS directly. And then it has a modem, and that modem is kind of like the cellular modem you have on your phone, but it works with satellites. So it can send messages from anywhere in the world using satellites and send us back the data. That way we don't have to pick it back up to get the data. And that's pretty important in a hurricane or in the sea ice, when sometimes it won't be possible to get the buoy back. So we want to make sure we get the data back. Now, I'm sure you're wondering, well, what happens to that buoy? Eventually, those buoys, they do often wash up on beaches, and they all have a sticker on them with a phone number. And you'd be really surprised how many we get back. We get calls from all over the world, and people say, hey, I found your buoy. What do you want me to do with it? And I say, oh, hang on, I'll send you a box, and you can send it back to us, and we'll give you a big thanks, and I'll send you a hat, and we'll reuse the buoy. So we do end up getting a lot of these back from just good citizens who are trying to help us out. So that's the electronics. Here's what it looks like to deploy. There's Laura is one of the postdocs in our group, and this is her deploying one in the Arctic Ocean a couple months ago. I imagine this looks a lot like what the One Ocean does when they deploy. It's pretty easy. You just toss it in, and usually you're smiling when you do it. Hopefully it's a nice, bright, sunny day, but it might be kind of rough out too, because that's when there are waves. So anyway, you just toss them in, and then they float at the surface, and the little yellow part you see at the top, that's the part that sits above the surface. So the water line is just below that yellow part. Most of it is resting below the surface, and that's where the batteries are. So the batteries are heavy, they're down low, and the rest of the buoyancy is up high. So that makes it pretty stable in the water. And then it rides up and down with the waves, and it makes that wave measurement. We usually measure a few other things also. We always measure the temperature. You've already heard the team talking about how warm the ocean is in that region right now. And that's a key parameter for lots of different people working in the ocean. So we almost always measure the temperature. That tells us how much potential fuel there is for a hurricane to get started, because it's really all about the heat that's in the ocean. And it also tells us what the conditions are for any of the biology that's happening. Temperature is a really key one. So we always measure that. Sometimes we also measure the conductivity, and the conductivity is something we use to determine how much salt is in the ocean. So of course the ocean's salty, but that saltwater content, that varies a little bit, so we can measure conductivity. On some buoys, we also measure turbidity, and that tells us how clear the water is or how murky the water is, and that tells us how much sediment is in the water. So if you're near a river mouth, then there could be a lot of sediment coming down the river. Or if you're out in the middle of the open ocean, then the ocean might be really clear, bright blue, and there would be very little sediment in the water. And then the last thing, sometimes we measure the radiance. That's the amount of sunlight coming in from above, and that's also really important for the biology. The idea is that these are relatively inexpensive. They cost about $1,000 for us to make them. We make them at the university in my lab. That's still a lot of money, but it's much cheaper than buoys used to be. When I started working in this field, the buoys were about $70,000 each. So now we're able to make something for $1,000, and that means we can make more of them, and we can do more with our research funding and put more of these out, because things change a lot as you drive around the ocean. There's places where the waves are really big and the temperatures are quite warm, and then you go to a different place and it's different. So we really need to be able to make measurements around the whole ocean. Okay, so let's talk about hurricanes, because the team just wrote out a hurricane, and I want to show you some of the data we've had from hurricanes and with these buoys. So here's an example of some folks headed out to deploy buoys with an airplane ahead of Hurricane Milton. Hurricane Milton happened in 2024, and it made landfall on the west coast of Florida. So you can see the inset there. There's a map of Florida. The black line is the track of the hurricane going over Florida. It came right after Hurricane Helene, so you might have missed, if you weren't watching the news carefully, there were two hurricanes that came in quick succession and did cause a lot of damage, and it was pretty dangerous for some of the folks who live there along the coast. So we put out these buoys from the hurricane, and we put out a lot of buoys because you don't know exactly where the hurricane's going to land. You have a forecast for the track, and you have a forecast for the intensity, but those are just forecasts, and they're not perfect. There's a lot of effort to make them better and better and better, so we can provide people with warning and people can plan for where to be and how to be safe, but the forecasts are not yet perfect, and that's why we're still doing the research. So this was the the approach we took was to put out a lot of buoys and make sure that even if the forecast changed and the hurricane didn't go quite right where we expected it to, that we'd still be able to make a good measurement, and then that measurement can be used to improve the models in the future. So this black line is where the hurricane actually went, and then the purple dot is the buoy that I'm showing data from. So all the buoys collected data, but the purple one is the one that came the closest to the hurricane, and you can see that it's a time series. So time is the x-axis. It goes from October 9th to October 10th to October 11th of 2024. And then the vertical axis, that's wave height in meters. And in the middle, as the storm passed over on October 10th, the wave heights were almost 31 meters. So in feet, that's about 35 feet. So those are waves that are the size of a big house, you know, a 3-story house. These are really big waves. These are terrifying waves right in the middle of a hurricane. And those waves are obviously very dangerous to any ships or anyone out there on the water, but they also cause a lot of destruction at the shore. So that's why we want to be able to measure these and be able to make better forecasts of these waves. And it's the same story I started with. You need strong winds to make waves, but then it also depends on how fast the storm is moving, how big the storm is. Those things will control the duration, how long the wind is doing its work, and the fetch, the distance over which that wind is acting. And those two things combine together to make the eventual total wave height that we get in an event like this. So that's what it looks like to have one of these buoys in a hurricane. I also want to talk a little bit about the Arctic, because this team just sailed through the Northwest Passage, and that is how you get across the Arctic. And that's also where I just was. I got home late last night from a trip to the Arctic, and I've been out for a month making measurements in the Arctic. So I want to show you some of these buoys in the Arctic and make the connection back to where the team was a few months ago and some of the science that's happening up there. So that video that we just saw, that's a video of a buoy being deployed from an airplane into the Arctic. You can see there's sea ice below, and that buoy is going to land in the mixture of open water and sea ice and make measurements of the temperature and the waves. So that's a good visual on how we do some of these deployments. We also do them from ships too. And there's another picture of what the buoys look like, and here it is in the water. And then here's what we just recently had out. We had a lot of buoys out just north of Alaska. So here's the north coast of Alaska. This is called the North Slope. The village of Utqiagvik is here, and Point Barrow is here. So the One Ocean, they came by, went around like this, left the Chukchi Sea and entered the Beaufort Sea, and then kept going eastward through this region here earlier this summer. So we had all these buoys out here, and here's some of the kind of things we see. We see waves in the ice. This is an older video from being up there before. And this is something we see a lot in the late fall when the ice is forming and there's storms happening at the same time. We see this particular type of ice. And this ice has a very easy name. It's called pancake ice because it looks like pancakes. And this is an ice type that occurs when there are waves, and the waves cause all the pieces of ice to collide with each other, to go. And as they collide, they move around a bit randomly, and they shave all the corners off the shapes they're making, and they end up with something that's mostly round and looks like a pancake. So we call this pancake ice. And this is an ice type that we saw a lot of when we were just there in the last few weeks, as the ocean is starting to freeze up for the winter, and the waves are rolling through with the big fall storms. And eventually, as the storms, they calm down, then these pancakes all start to freeze together. We say they weld together, and they eventually make the winter ice pack. So this is the kind of thing we see and we measure with the wave buoys. And one of the things in particular we measure is how the surface is smooth or by the presence of the ice. So the ice provides some damping on the waves and smooths out the waves, and that's one of the things we're studying. The other thing that's happening in the Arctic is that in general there's less ice, and that means a ship like the One Ocean expedition is able to get through the Northwest Passage. Still not easy, but something that's feasible these days that wasn't feasible 100 years ago to take a small boat through the Northwest Passage, and that's because there's just generally less ice. As there's less ice, there's more waves. So if we go on this left graphic here and we look at what the ice cap looks like in the summertime, it's this white object here. This was a few years ago in the summer of 2020. The yellow line here is what the ice would have looked like back in the 1980s. And now in the summertime, there's just a lot less ice. And this is a very clear signal of our warming climate. There's less ice in the summer in the Arctic. Now, for the most part, the ice returns in the winter. The whole Arctic refreezes in the winter because it's very cold and dark. But that ice is in general much thinner and much younger and doesn't persist into the next season. So this seasonal cycle has really changed. And there's all this open water in the summer now, this blue region here. So you used to only have this much space between the coast of Alaska and the summer ice pack, and now you've got 2 or 3 times that much. And that is an increased fetch. There's that word again, the fetch. And so if we make a lot of measurements throughout this region over many years, we see a classic signal of more energy when there's more fetch. So one of the key changes happening in the Arctic right now is less sea ice and more waves. And we see that in trends. If we look back through our historical data, we see a line trending up, that the waves are getting bigger throughout the Arctic. The wave periods are getting longer, which is also related to fetch, even though the wind speeds aren't changing that much. So you can have the same winds, but if you have more room for the waves to grow, they will get bigger. And that really affects the people who live up there, because they're starting to have a lot more wave energy arrive at the coast, and that causes events like this flooding event that flooded the village of Utqiagvik a few years ago and caused much of the town to be impassable, and some of the roads were covered with water and impassable. This village also uses ice cellars below their houses to store the food for the winter after they've done all their hunting and fishing throughout the season. And those ice cellars were flooded, and then food was ruined, and people were in a lot of danger of not having enough food. And here's another image of some of the Arctic coastlines, which are eroding really rapidly, and these increased waves are making a big difference. So there's some of the things that are happening in the Arctic. So I want to end by just putting up the map of the Americas again, and you've been following the route of this team as they've gone from the Washington State region up and around Alaska through the Northwest Passage and back down, and now are headed south and continuing on. And everywhere they go, they're going to see waves, and they're going to see changes in the ocean temperature. So that's what these buoys are adding to the expedition, is to be able to measure those things and understand why the waves are big when they're big, and why and how the temperatures are increasing. So I'll end there, and happy to take a lot of questions.
Perfect. Thanks, Jim. I'll take that backstage. Let's bring in the rest of the team from backstage. There they are. And we are going to open things up to questions. So if you are tuning in via YouTube, don't be shy to use the chat sidebar. Send in some questions. We've got some high schoolers hanging out backstage. Question or two, you can give me a wave or put me a message in the private chat, and I'll come bring your crew with us front and center. But the first question I have here in the chat is, how many more deployment of the MicroSWIFTs do you expect to do between now and the end of the journey?
I think 7 more we have left. So we're going to try and space them out, because it's about 5 weeks worth of data that they collect. And so we'll try and space it out so we have them all the way back up to Washington again.
Okay. Next question I have here in the chat is about the damage to the sailboat. Was there anything significant that needed to be repaired after the hurricane passed by?
Well, yes, there were. We were very fortunate. We almost lost the dinghy. It came off the back of the boat.
No, he said that hurricane.
Oh, the hurricane.
We were okay.
Yeah,
we were lucky on that. The hurricane itself, Hurricane Melissa, we learned a lot from our crossing down, because basically we almost went through hurricane coming down the Atlantic. Now there we sustained some damage. When we were able to be very prepared and quite protected for Hurricane Melissa. And so with that experience and Mark's experience of going through that before, when he sailed around the world, we were able to really prepare for that one, and we experienced no damage on that.
Right. And the damage that we had repaired for the earlier storm all stayed intact. So we were all good. It was just a really anxious 12, 14 hours.
All right, good stuff. So sticking along that hurricane line, Jim, I've got a question here about dropping the buoys in front of hurricanes or into hurricanes. Have you done this for numerous years, and can you see a change in the waves, maybe the intensity as the years are going on?
We have done this for several years. The last 3 or 4 years we've done it. So we've sampled about 6 or 7 hurricanes, and Every hurricane is different. The waves we get from a particular hurricane really depend on the intensity, how strong the winds are, but also the size, because that sets the fetch, and then how fast the storm is moving. And there's this really interesting phenomenon where if the storm is moving at the same speed as the waves, you get something that's kind of like a resonance in physics. And so the waves can get particularly big in that case because the storm and the waves are moving together, and that gives the waves extra time to harness more and more energy from the wind. So we certainly see that signal. We do see over an even larger time scale, longer than we've been doing this, that hurricane intensity is in general increasing, and that's really related to sea surface temperatures. If you make the water warmer, that's the engine that drives the hurricane. So there is a very clear climate signal there of just warmer temperatures, especially in the Gulf of Mexico and throughout that whole region, that will drive more hurricane intensity, and that's a pretty clear, simple thing to say. What it means for exactly which waves you get, it really depends on how the hurricane forms and its track and its things. It's possible to have a Cat 5 hurricane with smaller waves than a Cat 3 hurricane if things line up just right. So there's some nuance to the extra part of that question, but the idea that we should be expecting more intense and more frequent storms, that's one that's pretty clear, unfortunately.
Okay. Another question about the buoys. Jim, do you have a story or a time that one ended up somewhere in a strange location or returned in a weird way?
I have plenty. One last year that was put in the Arctic ended up on the Kamchatka Peninsula, which is in Russia, right? If you go across from the Aleutian Island chain, you keep going west, there's this beautiful big peninsula that hangs off of Russia, like north of Japan. And so somebody, it was a middle school science teacher who found it on the beach and called and said, "What is this?" And said, "Do you want it back?" And they sent a bunch of photos, and it was so damaged that I really wasn't worth returning, and that'd probably be hard to do with customs and everything. But I did send a bunch of information and say, "Hey, if you can use this in your science classroom, as a demonstration of how we do ocean science, then go for it. I hope it's helpful to you. Here's some information." So that one was pretty far afield, right? That's a long ways away. And then from some of the hurricane sampling in the Gulf of Mexico, we certainly had them wash up both along the Texas coast, Mexico, and in Mexico, and had a lot of phone calls from people. It turns out the park rangers are great. They wash up on a lot of state parks and community parks and things and beaches. And who's out on those beaches every day? The park rangers, right? Or the beach cleanups volunteers, and we get a lot of phone calls from those folks. And boy, anytime we can reuse a buoy, we love to do it, right? We get more data, without spending our precious research funding. So, we do get some funny phone calls.
Okay. Muffles High School is hanging out backstage with us. I'm not sure if they have a question, but I think it's still worth bringing them in just to see their faces. How's everyone doing? What do you think, Miss Rocket? Any questions back there from the students?
Do you have any questions? They came in a little bit late, so I'm not quite sure that they fully understand the whole discussion, but please feel free to ask a question if you have it.
I think it would be fair game too. We've got some ocean experts here, some people who've explored and built cool technology. If you have any questions about ocean careers or studying the ocean, I think those would probably be fair game too, as well today.
Great. These are seniors, and they live right on the ocean. So hopefully they're interested. Do you have any questions about that?
That's okay. I'm gonna. Oh, we do. Okay.
Do whatever you want.
You can come up. You can shout it. Whatever's better.
Good for you. Yeah, you can hear her.
Nice and loud. Yep.
What was the hardest part of developing the buoys?
The hardest part. We couldn't hear that, Joe.
Yeah, the hardest part about something with the buoys.
Developing, I believe
Developing.
That probably for the University of Washington, doing and engineering and building it. Yes.
Yeah. I think the hardest part about developing those buoys was making sure that the measurement was a really high quality. So calibrating the buoys and we did a lot of testing, because what we were trying to do is replicate something that was really expensive, almost $100,000 US to build these buoys previously. And we said, we want to get this down to $1,000. So, dramatic decrease in cost, but we want the same data quality. We want really high data quality. So we spent a lot of time trying to make sure we could measure the motion really accurately, doing side-by-side tests with the expensive, previous buoys and put the new buoys right next to them. We did that in the ocean quite a bit, but we did a lot of testing leading up to that. We used a bicycle stand and this big rotary drive motor to have the buoys go around and around, just like that cartoon, that orbit that the buoy traced out. And we did all this calibration where we would do different periods, different time cycles going around and around, and different amplitudes with a different arm on the device going around and around to make sure that we could measure accurately waves that were really small going really fast, waves that were really big going really slow, all the different scales of wave motion, and make sure that that was really accurate before we just started building a million of these things, because that would be silly, right, to build a bunch of things but have a bunch of bad data. So that took a lot of time and a lot of effort. There's several years just doing that.
Thank you.
All right.
Has your research led you to any investigations around the Caribbean Sea and around the Americas where you have any interaction with the Caribbean Sea?
Okay, so a question for each there. Jim, wondering about, has the research, because this group's in Belize, so they're wondering if the research that you've done has been in the Caribbean Sea, maybe in their area of the world, and then around the Americas. I think they're wondering how close you're going to get to their part of the world.
Okay, I'll go first. I haven't worked in that region very much. I have been to Belize once, and I had a great trip. I loved it, and I got to go sailing all up and down the coast, and it was one of my favorite trips of all time. It was just such a beautiful place. So but I haven't worked there very much. Our work is often funded by proposals that we write to get funding to go do something. And I do have a proposal right now to study sargassum, the seaweed that floats on the surface of the ocean, and to try to understand where that ends up. Because sometimes you get a ton of it that washes up on a beach somewhere, right? And that kind of can make a mess. And so we're trying to understand, why does that end up in some places and not other places? And some of that is the wind and the waves and the currents that force it. And so the kind of things I study are usually about the physical aspects, like the winds, waves, and currents. So I hope to work on that in the future, but I don't know yet if I have the funding to do that. But I did just write a proposal on that that's sort of relevant to the region, because you have all that sargassum. It's called the Sargasso Sea, right? You have this stuff floating around everywhere, and sometimes it washes up on a beach. So there's my answer.
Yeah, Belize is definitely struggling with that. Can you tell us how that's happening and why this coastline and the Keys are getting so much of that?
I don't have a good answer for that yet. That's what I would like to study, is to understand what the patterns are of where it ends up and why. It sort of has to be something about the circulation and the patterns that drive it to that location. But I don't have a good answer for that right now.
We're definitely familiar.
We actually happened to see an awful lot of that as we did our crossing here for the last 1,000 miles. We saw massive patches of the weed, and it would be in forms like long lines as we sailed past it, but it was constant. And sometimes it was huge patches, sometimes it was just smaller, but every day, all day, we saw the weed as we went across. So that was really interesting, and I forgot what the other part of it was.
Well, it was from how close to Belize. So we're on the east side of the Caribbean,
yes,
which is where we'll put another buoy out.
Yeah.
But we won't be over that far.
Yeah, so do watch, because we will drop another buoy probably in the next week or so. We'll drop another buoy out here in the Caribbean Sea, so you can watch that one. And that should give you some interesting information about current and what's happening out there. So we will be dropping another one shortly. Okay, thank you. And we're really neat to hear that you're watching us in Belize. That's really cool. So thank you.
Thank you.
All right, very cool. Thanks, Muffles High School. Thanks for those great questions. Thanks for hanging out backstage today. Okay, Jim, can these buoys, so this is a two-part question, can they get smaller and cheaper still? And do you think there'll ever be kits where people could maybe build one at home, like citizen science?
Those are great questions. I love those questions. I think they can get smaller and cheaper still. The thing that really drives the cost right now is that satellite modem. It uses the Iridium satellite system, and that's a few $100s just for that one part. So that drives the cost. And then having a good housing that with those O-rings that keeps everything, all the electronics dry inside. That's the other thing that really drives the cost. And the rest of the electronics are pretty cheap. So I think that'll come down. Satellite communications are changing rapidly right now. There's Starlink and there's all these other things happening. And we could build buoys that were just cellular modems. Those are a lot cheaper, but they'd only work near the coast. But that could still be a great application, just having those measurements close to the coast. So we have a few things in mind there, and I think the idea is, keep driving the cost down. And then the idea that others could build these, I love that. And we actually have what the team has right now is what we call version 2. So we have been doing some iterations, and the version 1 designs, every little inch of it is posted on GitHub from our lab group and is entirely reproducible. It's all open source, and someone could download that. It includes the files to 3D print everything. And so, a high school classroom with a good maker lab could make those tomorrow if they wanted to. And it's all there, the code there to run on it. That version works on a Raspberry Pi, which is pretty readily available. And if people have a little bit of Python coding experience, then they could learn how to do that. And again, the code's there, so there's a template there. You don't have to know too much of it, but it'd be a good learning experience. You could try to get under the hood a little bit and learn a bit more. So yeah, I'm hopeful this gets picked up and adopted a bit more like that.
All right.
That's really interesting, Jim, because we have had people emailing us about these and if they can purchase one, or whatever. So I wasn't quite sure, but this is really fascinating. Thank you.
Okay, to do a quick speed round here through each of the screens I have right now. Jim, you just got back from the field. Do you have a little time at home now, or do you have to head out again soon?
Unfortunately, I don't. I have to go to Halifax. But I love Halifax. It's a cool place. We just finished a project in Baffin Bay. We were kind of just on the heels of these folks as they came through, and we had a different platform there called a wave glider. We had 2 of them, and they're little autonomous boats that drive around and they use the waves for propulsion, and they make the same kind of measurements. But we can actually tell them where to go. These little buoys, they just drift. They go wherever they want to go, and sometimes it's not to the most convenient places or not where we get the best data. So the wave gliders, they go, we can drive them remotely and tell them where to go. And we just finished up an experiment watching the Baffin Bay start to transition to freeze up. So I need to go and get the data off those and pack them up and make them ready to come back and ship. So yeah, busy, but all good things.
Yeah, we've been in contact with Jim where he's been, and I would talk to him a little bit about the storms we're about to encounter. So it's been pretty neat, and I love the fact that we are, connecting all these scientists together, because even these little guys here are offering an awful lot of information. Even we had last week whale researchers, and then they're using some of this information to just find out what's happening in our oceans. Like if you're going to the doctor, they take all these different things to see how you're feeling. Well, this is part of that information for the ocean, is how is the ocean feeling? What's happening out there? And a lot of our researchers are, connecting together to look at our one ocean and see what's happening. So this is fantastic stuff, Jim. Thank you.
Okay, Grace, question for you now. You've been on land for a little while. When do you catch up to the team?
Yeah, so my plans are to catch up with the team down in the Falkland Islands, which is very, very south of South America for people that don't know. So hopefully January, I believe, is the timing for that. So kind of soon. I'm excited to get back on the boat, especially to start up some kelp studies. That's going to be our next kelp sites there. So I'm pretty excited for sure.
Yeah, the Falkland has a lot of the bull and giant kelp patches, and they've caught those on the satellite, so we have imagery of what patches we're going to study while we're down there. So it's pretty exciting. Looking forward to it.
Very cool. And then to our team hanging out in Puerto Rico, how long are you going to be there soaking up the sun?
It's not a holiday.
Honestly, we have, like I said, it's going to be pretty busy for us. Right after this, we have to go and start provisioning for possibly 5 weeks offshore. So we have laundry to do, we have cleaning of the boat to do, we've got all kinds of grocery shopping to do.
Maintenance, groceries.
And maybe go buy a couple of tank tops because it's awfully hot. It's pretty different from the Arctic, right? It's just been quite a transition for us mentally. Is here we were in the Arctic, out on the deck in snowstorms, and we're now really, really hot.
Probably will be here another 4 or 5 days.
Okay. Well, we still have one more event before the end of the month. That's coming up, I believe, on the 25th. So if classrooms want to check that out, you can go exploringbytheseat.com. And if you just go under the events, you'll find it there. You don't have to write down this whole big address. If you just go under the events, you'll find a page there for One Island, One Ocean. So, of course, we'd love to have you joining in with us. And then I know we'll have more dates coming soon for events further down the line as you guys make your way towards South America, which is pretty big to get to another continent. So that's pretty cool. Jim, Grace, team in Puerto Rico, thank you so much for hanging out with us today. It was great to have this connection and nice to put a little more detail to the MicroSWIFT buoys that we've been dropping along the way.
It's always a pleasure, Joe. We want to thank you. And we have been discussing one of the classrooms we were talking about is actually that link from students to how they could possibly work on the ocean. And it comes in all kinds of forms, from either being a scientist to a mechanic or engineer or, all kinds of different trades. So that will be one of our classrooms that we'll be highlighting in the new year here. So thank you very much for meeting us again. We really appreciate it. Thank you, Jim, for your time. We love working with you. It's been fantastic. So thank you very much.
All right. Shout out to our classrooms for joining us today as well, and those who will tune into the recording. One more look into Belize. Thanks for hanging out with us today, high schoolers.
Thank you. Yes, thank you.
We're going to sign off for today, and we'll see everybody again, hopefully later in November. Thanks, everyone.
All right.
Thank you.